Dear students, today we will discuss about the insulator. Insulator means at normal condition there is no any free electrons. Here I am taken one atom. In this atom the positive ions are in the nucleus as shown here, and these are the bounded electrons in the valence shell. Let the force between positive ion and negative ion is Fi. The force applied on the free electron is Fa. If the voltage applied between positive ion and negative ion, the electrical field is produced around it. It is represented by capital E. The capital E equal to V by D, where V is the voltage and D is the distance between the positive ion and negative ion. The units of the electrical field is volts per mm. Now I am giving the definition of the electrical field. Electrical field is an effect in space due to which a charged particle experiences force. This force is called applied force. The applied force is represented by Fa. We know that Fa equal to E capital E, where capital E is the electrical field, the small e is the electron charge. We know that electron charge equal to 1.602 into 10 to the power of minus 19. If the force between the positive ion and negative ion is very strong and its value is higher than the force applied on electrons, then the electron is not move away from that. This condition of atoms are called insulators. Again I repeated here, if the force between positive ion and negative ion is very strong and its value is higher than the force applied on the electrons, then the electrons is not move away from that. This condition of atoms are called insulators. Now I am giving the definition of the insulator. Insulator which do not allow electrons or charged particles to move freely within them. Again I repeat the definition of the insulator. Insulator which do not allow electrons or charged particles to move freely within them. Now if voltage increases, electrical field applied increases, and then force applied on the electron is also increases. If this applied force greater than the force between the positive ion and negative ion, the electron attached in insulator leaves from that and goes to nearest atom. Then the electron in nearest atom goes into the next atom. So what we will see, the charge is getting conducting. This condition of atom is called conductors. For example, if we take the force between positive ion and negative ion is 10,000 newtons. Now we applied force on valence electron is 5,000 newtons. Then electron is not move away from that because the force between positive ion and negative ion is very strong than applied force on free electron. Now we increase this 5000 newtons to 10,000 newtons. Then what happened? Now we observe the force between the positive ion and negative ion is 10,000 newtons and the force applied on the free electron is also 10,000 newtons. In this case also the electrons not move because the force between positive ion and negative ion and the force applied on the free electron both are equal. Now we applied the force on electron is 10,001 newton. In this case the applied force is greater than force between positive ion and negative ion. At this condition the electrons moves away from that atom and goes into the nearest atom. Therefore now it becomes a conductor. Here we are observing 2 points. The first observation is, here it is not allowed to move charged particle up to applied force 10,000 newtons. This amount of force is known as dielectric strength. Up to this point, the valence electrons not move away from the atom. It is called insulator. The observation 2 is, the amount of force 10,001 is breaking the force between the positive ion and negative ion, and it attracts toward them. Then the electrons moves away from that atom to nearest atom and it becomes conductor. This amount of 10,001 newtons is known as breakdown of electric field. Now I am giving the definitions for dielectric strength and breakdown. First we observe the definition of the dielectric strength. The dielectric strength of an insulator is the maximum strength of the field it can withstand without becoming a conductor. Again I repeated the definition of the dielectric strength. Dielectric strength of an insulator is the maximum strength of field it can withstand without becoming a conductor. Now I am giving the definition for breakdown of electric field. Breakdown of electric field is the maximum field around the insulator required to conduct charge through it. Again I repeated, breakdown of electrical field is the maximum field around the insulator required to conduct charge through it. That means breakdown its insulator. So this is the total description about the insulator or dielectric. Thank you. We will meet in next class.